Hey guys, Jake here, coming at you with another math lesson today. Today we're going to be talking about the change of base formula, kind of continuing on with logarithms and, the discussion of how those functions work. Let's go ahead and just jump right on into it. So basically the change of base formula tells us if we have a, b, and x that are positive real numbers, such that a does not equal 1 and b does not equal 1, then log base a of x can be converted to be a different base as follows. So like I've been saying in some of my recent videos, I really want to take a deep dive into, in general, I want to take a deep dive into kind of textbook explanations of different math concepts. I think it's really important, and I want to kind of teach you how to interpret this kind of stuff because I think a lot of people see an explanation like this and they're like, that's another language. How am I supposed to understand what this means? Well, it kind of is another language. You need to learn how to speak that other language. And if you do, and if you can, learn that language, then you can pretty much learn any math concept you want just by picking up a textbook and reading it. So I want to really teach that on my channel a bit more. So let's kind of dive into what these two sentences are saying. I know it can be weird when you start mixing in variables, letters, math, all in one kind of jumbled mess. So let's talk about this. So whenever you have this kind of, let A be an X kind of thing, basically what that's doing is kind of introducing what the variables or constants are in the equation that it's about to get to and explaining what sort of limitations there are on those variables or constants. So in this case, we know we're going to have an A, a B, and an X, and they're all going to be positive real numbers. Okay. We also know that A cannot equal 1 and B cannot equal 1. So, it should be okay for X to equal 1. You just want to make sure that A and B are not 1. So then what I find helpful is to kind of jump into what is the actual formula that we're looking at. What is it telling us? So basically, and sorry, you can see down there, we're about to get into an example in a bit, but just kind of looking at these three formulas right here, we have kind of three different situations. You can see we have an A, a B, and an X in all these. And basically we know as we look at this formula, which don't worry, I'll get into a little bit more of what this formula actually is telling us in a second. But just to kind of talk about what these introductory sentences are telling us, we know that A, B, and X in this formula is going to have to be positive real numbers. So keep in mind, you can't have any complex numbers, any imaginary numbers. You can't have any negative numbers. Okay, so those are all going to be positive real numbers. They also can't be zero. We also know that A and B, so we have an A here, 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 A and B, right? These A's and B's also can't be 1. Okay, so just keep that in mind. Basically, what you really want to kind of keep in mind with that sort of a thing is when you're looking for times when you can use this formula, go ahead and see what happens if you use it. And then if you notice that whatever sort of a situation you're running into has a 1 where the A or the B is, or a 0 or an imaginary number, or a negative number where the X is, or, any of that sort of a thing, then okay, I can't actually use this formula like I thought I might be able to. Let's see what other formulas there are I can use. So it's really just kind of like be aware that if you're trying to apply this formula in the wrong situation, it's not going to work. So just be kind of careful of that. So you really are just kind of looking for what those conditions are that you need to make sure are being met in this situation. When you're looking at a generic formula, it can be kind of hard to, kind of think of the context like that. But once you get to an example, which we'll do in just a minute, it's a little bit easier to kind of see where those numbers are comparing. Okay. So if we know that those conditions are met, then log base A of X, so notice all three of these formulas down here start with log base A of X, can be converted into a different base. So there's three different situations. We can convert this into either base B, base 10, or base E. Basically, the idea with all three of these situations is we are taking a log base A of X, log base something of something, and we're converting that into another equation that uses logarithms. But essentially what we're doing is, notice we're picking the base we want. So we either have base B, we have base 10, which the base is not written here, but if there's no base, if it just says log of something, that implies base 10. And then we have natural log. So ln is just log base e. That's just kind of a shorthand to represent log base e. So we've kind of chosen our e as our base for both of these. So basically this formula, it allows us to take any log we want and convert it into basically an equation using two other logarithms, but we now get to choose the base of those other two logs, which is super nice. Doesn't sound nice. It sounds like, we've just overcomplicated it, but here's why it's nice. A lot of calculators don't have a button that allows you to type in log base a of x. They don't have a button that allows you to change the base of the log you're typing in. So you may end up with something like this, where you want to evaluate log base 7 of 4 and say, okay, log base 7 of 4, that's just some number. That represents an actual number. We can plug that into a calculator and see what number that is. However, your calculator probably can't accept this as an input. It might be able to. Some calculators can, but a lot can't. So you may be looking at your calculator like, oh, well, great. Now what am I supposed to do with this log base 7 of 4? How am I supposed to calculate that? Well, you have this change of base formula allows you to do just that. Because what your calculator can accept as an input is log of x divided by log of a, or natural log of x by natural log of a. So this formula, the log base b one, where you get to change the base to basically whatever you want, it's a little less useful because you're still in the same situation calculator-wise. There could be other situations where algebraically that allows certain things to cancel out in a nice way, but that's, less common where that's useful. These two are going to be useful a lot anytime you're using a calculator to evaluate a log. So really the key is with this change of base formula is you're taking whatever the base is and putting that to the bottom of your fraction. So the log of base a, the a is contributing to the denominator of your fraction. The thing that you were taking the log of is contributing to the numerator. So how I remember this, it's very simple. The base is written lower than the thing you're taking the log of. Therefore, the log of the base should go on the denominator, written lower than the log of the thing that you're taking the log of. So you're going to basically change log base a of x to log of x over log of a. And then you can pick whatever base you want for those logs as long as the base is the same. So as long as we have log base b, log base 10, log base e, as long as the base of the logs that you've converted to is the same base, this is going to hold up. And then, obviously in this sort of a situation, we want to evaluate log base 7 of 4. We want to check back to our conditions and make sure that it doesn't break any of those rules. So is our a, our b, and our x all going to be positive real numbers? Is a and b not going to be 1? If so, then we should be good. So, we don't have any 1s in here. We do have only positive real numbers. So as long as the base that we are artificially choosing, which is most likely base 10 or base e, as long as that base is also not 1 and is also a positive real number, we should be good. Which, again, 10, e, those are both positive real numbers. E is just a known constant. It's like pi. It always means the same number. It's like 2.7. So you can always use that as a positive real number, which is not 1. Okay. This is a formula that is addressed on my Precalculus study guide that I came out with recently. Go check that out. You can go to jakesmathlessons.com/precalculus-study-guide or scan this QR code in the upper right-hand corner of your screen. And that'll take you straight to a page where you can read more about that study guide and get it for yourself. It is downloadable instantly, so you can have it within minutes or probably even seconds over there right now. But that's it for this video. If you found that helpful, be sure to hit that like button down below. And if you want to keep this brain train rolling, go click that video right over there. I promise it's going to be a helpful one too. Thanks, and see you next time.